Okay, our first talk is by Martin Ruckert, News from the Hint Project. And I'll just say that as I read the preprint, I saw a blast from the past. PK fonts. Who'd have thought?
Okay. First slide already on. I think the microphone is on too. I'm Martin Ruckert. Hello. I will report on the progress made in the HINT project over the past 2 years. You shouldn't expect too much because I have a full-time teaching job on the side, but I will go in retirement in fall. But it's an open question whether that will improve the situation. So, okay. PK fonts. One problem I worked on was displaying the glyphs. The first viewers that I had for the HINT viewer was Android. And Android mobile devices usually have a very high resolution, often 300 dots per inch or more. So good rendering of the glyphs was not really an issue. This changed when I implemented the HINT viewer for Windows and for Linux, because on a large computer monitor, the resolution is often below 100 dots per inch, and good rendering becomes really an issue. The usual rendering procedure is outlined on this slide, and I started with PK fonts, and PK fonts define black and white bitmaps at a fixed resolution. For HINT, for HiTeX, which generates the HINT files, the default is 600 dots per inch. And the graphics card will render a pixel on the screen by interpolating the pixels in the bitmap and thereby creating gray values for each pixel along the border. Now on a high resolution monitor, lots of pixels are inside the outlines, inside the glyph, and so they are black. But on a low resolution monitor, only a few pixels are completely inside, and most pixels are along the border. So you get lots of pixels with various shades of light gray. You see something like this here, and this needs improvement. So the obvious improvement were, of course, outline fonts, and I use now PostScript Type 1 outline fonts. And I render them using the free Type 2 library. This process produces gray value bitmaps that are optimized for the actual resolution of the screen. You see the view got much more defined than it was before. And now we can look at the first video clip. Hope that works. Okay. We will look at a demo that shows a 10-point computer modern Roman font on a 141 dot per inch screen, and there is also a magnifier window to the right that shows a cutout 8 times magnified, and we have left the Type 1 font and on the right the PK font. Now let's see. Okay, here you see the font, and we see the differences between this is on one side the PK font, and on the other one and while scaling, I don't re-render the outline fonts, so they show pixels. But when I stop rendering, I re-render, and then they get more defined. So this is the Type 1 font, and this is the PK font. So you see the differences. The differences are more problematic with small fonts. So when I change to smaller fonts, observe the initial M and the first vertical stroke, it disappears and comes back. And when I re-render, the outline font is clearly more readable than the PK font. So that was the first improvement here. Thank you. The next improvement was rounding of the positions of the glyph. And we see the same layout and see how the rounding of glyphs in vertical and horizontal size affects the visibility of the glyphs. Can we have the second video clip? Okay, it's a 10-point, a 7-point, and a 5-point computer modern Roman text. Same setup with a magnifier. You have one word here, and you can switch between. I change the size of the window, and it changes the margins, and so the things move. And you see the L of how it gets rendered in different ways, and so the movement appears to be smooth over the pixel grid. Now I switch on the vertical rounding, and the horizontal rule get more defined. And when I switch to horizontal rounding, the vertical strokes get more defined. And of course, best is if I switch on both roundings, and I also switch off the interpolation. Now, this is now the effect. You get clearly more defined. And that's the effect of rounding the glyphs means the intercharacter spacing wobbles. It gets very unsightly, and the vertical line spacing also wobbles by pixel by pixel, which is less distracting than the changing intercharacter spaces. But that's, well, a consequence of rounding to pixel positions for small fonts, because the intercharacter distance here is only 1 or 2 pixels. So rounding means you increase the spacing by 50% or decrease it by 50%, from 2 pixels to 3 pixels back to 1 pixel. So this is the disadvantage for getting good glyphs. What I have now is a threshold in the viewer. When the font gets too small, I start rounding the glyphs to pixel positions. If you have big fonts, then that is not necessary. Because if you have a character distance of maybe 10 pixels, it really doesn't matter if you have a half a pixel more or less. But if the character distance is very small, you want readability. Okay, then let's look at the next thing I changed. I implemented links, labels, and outlines, and thanks to Ulrike, there is a growing LaTeX support for these features. And while we learned to navigate real books already in school, this skill, how to navigate books, is almost useless when it comes to big electronic books. So we actually need links and labels for navigating books, big documents. And there is one big difference between going to a label in a PDF file. You just need to switch to the right page. Whereas in a hint file, there are no pages. You have a label somewhere in your document, and you have to generate the right page at the given space in your window for that label. So you pick some text preceding the label and some text after the label, and try to get a nice page with 2 good page breaks that fits around that label. So that's an entirely different program. We have to generate the target page. Okay, let's look at video clip number 3. We look first at TUG, the program, Don and Knut's TUG file, generated by CWeave, the current CWeave that generates links and labels. We look at paging and look at the home page. Well, here is the HiTeX file. I'll open it. Well, I make it a bit bigger so that you can read it on the beamer and increase the font size. Okay. This is the Windows version, which is mouse-oriented, so you can page forward. And there is a home button to the right that brings you to a user-defined home page. Here it's a table of content, and you pick a section, 172, click it, and it brings you to the right section. If you don't want to use the home page, you can also open outline window. It's an operating system generated window where you have the major sections, the start sections, and you can click on them. So here's the introduction. This is a table of content, and you can go down to the index, go to the next page here, pick some section 1, 2, 3, 5, and it brings you to the right section. You can follow the links here, brings you to another section. There are also sections that you can use. You can go back using this link. So you can navigate the document using these links. I show you another example, which is a document specifying the hint file format, and it uses a different design. It's also a literal program, but it has a more traditional table of contents, and there are no page numbers here. But it still gets you somehow to the right section. The outline window has a hierarchy, so you can hide subsections like 4.8. You can open and close the major sections as usual. Go to the labels. There's also an index here. And as usual, indexes display page numbers. Here we have, again, these little arrows, because I don't have page numbers. And you can go to the place where aux name is used, and you get a page that just starts somewhere and ends somewhere where the system thinks that's a good place for this label. So it starts somewhere, and it shows the use of this aux name. This is how links and labels are implemented now. Next topic that I worked on, oops, here. No, okay. We need to, this is still the video clip. I think I need to get back to the slides. Okay. Is it wrong? No. Can we go to the next slide somehow? This doesn't seem to work. This is a clip that we have just seen. I would like. Okay. These are the slides. Okay. Okay. This is the next topic. Macros that cope with variable page sizes. And I have two examples. The first example is centering text two ways. One using the centerline macro, and the other one is using left and right skip. Can we see clip number 4? Okay. The centerline macro is just a horizontal box with fill glue, and there's no line breaking in a horizontal box. So it's better to use a vertical box. This is the output, and here is the source. So it's just a center line. And in the vertical box, I use a right and left skip that can grow, and a fixed inter-character space. So if I change the window size, the center line starts to stick out, whereas the vertical box, the paragraph is just reformatted. Okay. So the vertical box just performs better than a horizontal box when it comes to changing page sizes. Okay. Now, the next clip shows a more advanced example where we have side-by-side a left adjusted part, a center part, and a right text. Can we see the next video clip? Okay. Again, we try using a horizontal box and fill glue, and the alternative is a VTop box. And here is the source code. The fill glue will just make sure that the glue on both sides of the center text is of equal size, but it does not really center, except, of course, if you ignore the size of the left and the right text. Then the middle text gets centered. Here we have 3 boxes with a fixed inter-character glue and variable amounts of right skip and right and left skip, or only left skip. These are the differences. And we have just left skipped in the right one. Now let's look at the output. Okay. You see in the first 3 lines that only the third line really centers the center text, but ignoring the size of the left and right text will have its own consequences, which you will see in a moment. Well, the paragraph breaking makes sure that the middle text gets broken. And of course, if you ignore the size of left and right text, it's ignored. That's what it does. So this is an open field of designing macros that work well with variable page sizes. When you make something smaller, the title, for instance, which is centered, should somehow adapt to the width of the page. Next topic. Can I get back to the slides, please? This is the clip again. I don't want. Can you stop the clip? Okay. This is the slide. Okay. No, this is not right. Yeah, okay. Then I try to get that forward. Okay. There is also a new feature that converts a hint document to plain text strings. And this feature is now used for generating the outlines, because the operating system just wants plain ASCII text for the outlines, and we have seen that already. And the other use is searching for strings, because you type in a search string, and that's usually plain text, and you want to find something in a TEG document. And there are a couple of problems. Ligatures are a problem when you do searching. Hyphenation and page and line breaks are a problem, and the difference between a glue and a kern is also a problem. Let's look at clip number 6. This is not the right clip, I think. This should be clip number 6. Can you stop this one and play clip number 6? Okay. This is the last clip, so. Okay. Good. Yeah, character encoding is also a problem, but it's not yet implemented using reasonable character. Okay, I open a document, go to the search input field, and I search the word difficulty. And I click here, and it finds the word in spite of a hyphen in it, and a line break, and interline glue, and an FI ligature on the second line. So this works quite well. Let's look at a different document and search for TUG. Works nice. Let's search for latex. So in LA, it finds the LA, but when you type the T, it no longer finds it because there's a glue between the A and the T, not a kern. And so you need to type LA space TUG to find it. Maybe that can change in the future. Let's look at searching for mathematics like A1. You see that the found string is in red, greater x to n. That works all okay. It finds the text. And let's try, well, still 2n, so it finds that formula. Let's look at x minus 3. The x is found, but when you type in the minus, it's not longer found. I suspect the minus is implemented as a horizontal rule. So no chance of finding it here, because it's not there as a character. Or it's in a different font. Yeah, that's one of the problems that we have here. Okay, so there is still something to do. Thank you, and I'm coming to the end. I implemented viewers for all major operating systems that share the same backend and almost the same front end. And there's some small code in between. The smallest is the Linux system. That's just 600 lines of code. And there is a page with resources where you can look at the different things. And I'm available for questions. Thank you.
Do you plan to support bidirectional typesetting? So having left to right text versus right to left, or even top to bottom, as in some Japanese texts?
This is a research project, and I have very limited resources. So yes, it would be possible to support bidirectional typesetting, but it's mainly a problem of the TUG engine that generates these files. The viewers have no idea of what they render. They just take the information of boxes and glues and whatever is there and render it. So they have no reading direction. The viewer would be the same, I suspect, but the TUG engine needs to be able to do that. It would also be possible to take a TUG engine that knows how to do that, like LuaTUG or XeTUG, and add a hint backend to it. That would be probably the better solution.
I'm interested in your conversion from the hint file to plain text. Do you create a canonical representation that you search for? For example, the hyphenation. A hyphen at the end of a line may be part of a hyphenation character, or it may be part of actual the word. Do you produce some kind of canonical intermediate representation where you search in, or do you take several variations where you search for?
The page builder builds a tree of boxes, glues, and these things, and I search basically that infrastructure, the same structure that I display. For ignoring hyphens, when I do the hyphenation, I leave a mark of where text stops and the pre and the post things get included and where it continues.
Oh, yeah.
So I can skip that. Like with ligatures, where you have also the original text that was replaced, and so I can go through that ligature text when I search.
So I've got a question here from the online chat I'm going to relay from Werner Lemberg. He says, why do you reinvent the wheel with font position rounding instead of using, say, free type in auto hinting mode, which automatically does the right thing? The auto hinter is sub-pixel rendering mode, providing quite good results for exactly this type of problem.
You mean the sub-pixel, you are interested in the sub-pixel rendering?
Yes, he asked about, he said that free type auto hinting mode has sub-pixel rendering, is what he asked about.
I wouldn't know how to answer that question yet. Maybe we can discuss it afterwards on a one-by-one basis.
Do you already looking to get this hint viewer ready for ebook readers? This would be really nice.
That was one of my first things that I did. I contacted the main manufacturers of ebook readers, and there was no interest in anything besides the formats they have already. But that was the starting point. I was very unsatisfied with the out of the computer programming, a mixed supplement and the ebook that came out for it. It was a nightmare. So I started this project.
Thank you very much.